In this short video, we're going to learn about how to decompose a vector into its components. And we're going to talk about 2D and also 3D. So first, let's look at 2D, which is simpler. So we have a Cartesian coordinate x and y. So that's the origin O. And the vector is this one. So that's vector A. And it has an angle theta with the x-axis. So we can represent this vector A as A and theta. A is the magnitude, is the length of this arrow. So now let's do projection. Draw a vertical line to x-axis. So get this AX. And draw a vertical line to the y-axis. And this vector is AY. Then we can write vector A as AX I hat plus AY j hat. And AX equals, right, using the trigonometry, we know AX equals A cosine theta. AY equals A sine theta. Okay, so let's look at in 3D, how do we decompose a vector into its component. So let's say this direction is x, that's y, the axis is pointing vertically up, and a vector A looks like this. It's vector A, and it has a projection in the xy plane. So if we draw a vertical line to the xy plane, then that's the projection of A, right, in the xy plane. And suppose A has the following representation. So A equals magnitude A and angle phi. This angle phi is with the z-axis and angle theta. So we need 3 components to determine a vector in 3D. And theta is the angle with the x-axis. So now this length, this vector's length is A sine phi. And A sine phi is like in the previous 2D example is A. Okay, and the if I project to the z-axis, then this component is A cosine phi. Okay, so now we can write down each component. So AX is this length, A sine phi, then times cosine theta. AY component equals A sine phi sine theta. That's the Y component. And Z component equals A cosine phi.